Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electromagnetic Fields and the lecture topic is Electromagnetic Model in Vector Algebra from Unit 1 Introduction. On completion, the students will be able to understand about electromagnetism and electromagnets and differentiate between scalar and vector fields and their properties. Electromagnetism. Electricity and magnetism are the different facets of electromagnetism. Here you can consider a moving electric charge producing magnetic fields, or a changing magnetic fields move electric charges, and a static distribution of charges producing an electric field. Charges in motion, that is an electric current, produces magnetic field. And also electric current can also be considered as an example of charges, that is electrons in motion. Electromagnets. Arranging wire in a coil and running a current through it produces a magnetic field that looks like a bar magnet. This is considered to be as an electromagnet. Putting a real magnet inside can show the magnet back and forth depending on the current direction, which is called as a solenoid. Electromagnetics is generally the study of the effect of charges at rest and charges in motion. Some special cases of electromagnetics are electrostatics, that is charges at rest, magnetostatics, that is charges in motion in a steady motion DC, and electromagnetic, which are charges in time varying motion termed as AC. Fundamental vector field quantities in electromagnetics are given below. Electric field intensity E, whose unit is volts per meter, electric flux density D and its unit is coulombs per square meter, and magnetic field intensity H with unit amps per meter, and magnetic flux density B with unit teslas, that is webers per meter square. What is a field? A field is a spatial distribution of a quantity. In general, it can be either scalar or vector in nature. Fields can be classified as scalar fields as well as vector fields. Scalars are quantities characterized by magnitude and has only an algebraic sum. Examples of scalar fields are atmospheric temperature and pressure. Vector fields are magnitude and direction. Examples are wind velocity and gravitational force in atmosphere. Electromagnetic field. This electromagnetic field is produced by interaction of time varying electric and magnetic fields. Voltage produces an electric field, and the time varying electric field will be producing magnetic field. Magnetic field may be stationary or time varying. It depends on the time varying current. When the current is varying with respect to time, then the magnetic field will also vary with respect to time. This time varying magnetic field will be producing an electric field, and we can consider an example transformer where flux is varying with respect to time, producing electromotive force. Scalar quantity. Scalar quantity is defined as the physical quantity with magnitude and no direction. Some physical quantities can be described just by their numerical value with their respective units without directions, that is, they are not having any direction. Examples of scalar quantities are mass, speed, distance, time, area, volume, density, and temperature. Vector quantities. Vector quantities are those which can be represented by both magnitude and direction. Types of vectors include zero vector, example unit vector, position vector, co-initial vector, like and unlike vectors, coplanar vector, collinear vector, equal vector, displacement vector, negative of a vector. Examples of vector quantities are linear momentum, acceleration, displacement, momentum, angular velocity, force, electric field, as well as polarization. Certain properties of vectors. Consider A, B, and C as vectors and M and N as scalars. Then, as per addition property, we shall say A plus B is equal to B plus A, that is obeying commutative law. A plus B plus C within brackets can be given as A plus B within brackets plus C. This is associative law. Then, as per subtraction property, A minus B can be written as A plus minus B within brackets. Multiplication by a scalar. M A is equal to A M, where A is a vector and B M is a scalar, which obeys commutative law. M within brackets N A can be written as N within brackets M A, which obeys associative law. Here A is a vector, M and N are scalars. M plus N within brackets A can be written as M A plus N A, that is distributive law. Similarly, distributive law can also be written as M multiplied by A plus B within brackets can be written as M A plus M B. A position vector is represented graphically by a directed line segment. A unit vector is a vector of unit magnitude and directed along that vector. Quiz questions on electromagnetic model and vector algebra. Define electromagnetism. What are the two types of fields? List few scalar quantities. Name some types of vectors. Thank you.